So with our special right triangles, 45, 45, and 90 are the angles inside the triangle that we're going to be looking at. So if we drew our special right triangle, we'd have one 90-degree angle, one 45-degree angle, and one 45-degree angle. That's what we mean by a special right triangle. Well, that's what we mean by those names, 45, 45, 90, 30, 60, 90. So the second one we could draw out, we would have one 90-degree angle, one 60-degree angle, and one 30-degree angle. Now these triangles are special for a reason. We can find a formula so that I could find all three sides of my triangle if I just know one side only. Knowing only one side, I can find all three sides. Whereas most of the time with right triangles, we have to know two sides to get the third. These are special because I can only know one side and get all three. So these each have their own formulas we're going to be working with. On this 45, 45, 90 triangle, two of the sides are the same, and the third side is x times square root 2. And I'll show you why in a minute. First, I just want to get the formulas out. The formulas are going to be the most important part of the notes. They're going to be what you're going to refer to when you do your assignment. So I wanted to put those first. But I'll explain why after we show the formulas. 30, 60, 90 is going to be a little bit different. We have one side is just x. One side is 2 times x. And one side is x times the square root of 3. So those are the formulas we're going to refer back to throughout all of class today. So let me show you why now. The easiest one to show the why on is the 45, 45, 90 triangle. If I have my 45, 45, 90 triangle, we're going to figure out why did this formula work? Why did we use those particular numbers? Why square root of 2? Why not square root 5? So looking at my 45, 45, 90 triangle. I don't know any of the sides. Mathematically, what do we call something we don't know?
Unsolvable.
Okay. An unknown. And when we have an unknown, what do we usually label it?
1 x.
X.
Oh, e.
William and Austin, this is your last warning, and then I'm going to move one of you. So, I'm going to pick a side. I'm going to call it x. Now, I can't necessarily call the other sides x as well. We don't know that all three sides are the same. But we do have something special about this triangle. What's special about this? About the angles inside? Liam?
Okay, not only do they add up to 90, but on each angle side, the corresponding side is equal to that.
Okay, so because these two angles are the same, we have two sides that are the same. And it goes, this angle here corresponds to the side across. This angle here corresponds to the side across. So since those two are 45, these two sides are both x. But I definitely can't call that third side x. I'd have to call
Why?
it something else. I could call it y, but I can't call it x. But I do know another rule of right triangles. When we have a right triangle and we know two sides, we can find the third side. And there's a certain theorem that would let me find the third side. What theorem lets us find the third side?
Is it a squared plus b squared?
Do you know the name for it?
Pythagorean.
Yeah. Thanks, Marcel, for raising your hand. They stole the glory. Okay, so Pythagorean theorem, a squared plus b squared equals c squared. We can use that to find our third side. The most important one was c. We have to make sure we do this in the correct order, Hannah. So c is the side across from the right angle. That's the side we don't know, so we're going to leave c squared alone. We don't know what it is. We don't have anything to replace it with. But the other two sides, instead of using the letters A and B, I'm going to use the letters I named them. I named them both X. So instead of the letter A, I'd use X. Instead of the letter B, I'd use X. So now we want to get C alone. I know this one's weird because we have still only letters involved. We don't even have any numbers involved, really. But we can still simplify this and get C alone. First, what do we know about the x squared and the x squared? What can we do with those?
Add the exponential
Same.
functions together.
We can add them. We don't add the exponents. We only add exponents if we're multiplying. We add the coefficients.
2x.
And then we have to get rid of the squared on the C. What's the opposite of squared?
Square root.
Square root. So over here we know square root and squared cancel each other out. On the left side we have a little more going on, so we're going to have to simplify using our factor tree. Now 2, that would only be 2 times 1, and we never want a 1 involved, so we just use 2 as it is. But x squared I could write as x times x. And then what size groups do we look for when we're working with square roots?
2 pairs.
Groups of 2, we're looking for pairs. So 1 dies, 1 makes it out alive, we get x times square root of 2. So, does that match what we had on the formula triangle I gave you?
Yeah. So that's the answer.
Yep.
Wow.
So that's our final answer. Well, for the y part. Okay. That matches our formula triangle.
Okay.
So that was just proof of why this actually works. The second one is a little bit more difficult, so we're going to skip the proof of the y part on this side. But it's the same idea where you'd have to do some Pythagorean theorem stuff going on. But both of these are what we're going to use to solve our problems. The purpose of the formulas are to give us, if we know one side on a problem, like this example, I only know one side on this example. 3. I don't know what A and B are. I know just the number 3. Well, we're going to use that formula triangle in order to figure out what A and B are. We're going to find all 3 sides just knowing one side. So we have a couple of steps to do this. Okay, you still have your notes written down. So our first step, we have to identify which one are we going to use. We have 2 formula triangles to look at.
45, 45, 90.
Okay. We have to identify if we think we're going to use the 45, 45, 90 or the 30, 60, 90. So Liam thinks it's the 45, 45, 90. Do you guys agree or disagree with Liam? Let's do a thumbs up if you agree with him, a thumbs down if you disagree with him. Do you think we should be doing 45, 45, 90, thumbs up, or 30, 60, 90, thumbs down? I should see everyone voting. Thumbs up or thumbs down? 45, 45, 90, thumbs up. 30, 60, 90, thumbs down. Okay. Okay? Most of you guys are voting thumbs up. Most of you guys, but we had a few people who thought 30, 60, 90. So let's ask why. Chris, you said 45, 45, 90. Why do you think it's a 45, 45, 90 triangle? Okay. We don't know enough about the sides to use that as our reasoning. Okay. Liam, why did you say 45?
45-degree angle.
Okay. Looking at the angles inside, one of them is 45 degrees. To identify, you're going to look at the angles inside. So we're not just picking it random. We're not even looking at the shape of the triangle to decide. Maybe, mine doesn't look exactly like the two sides match, but that's because I'm not that great of an artist. So maybe I just drew the picture a little bit funny, but we know inside it's a 45 degree and a 90 degree. So what's this last angle have to be?
45.
45. So on this particular problem, we're using the 45, 45, 90. So then we need to label all three of the sides like the formula triangle. So we have to refer to the top of our notes. Like I said, those first two triangles in our notes, they're very important for this assignment. You've got to have those down, or else you're not going to be able to do the assignment. So we've got to go and look at our formula triangle. Okay. I'm going to just copy it so that I don't have to keep scrolling up and scrolling down. After Kenya is not here. So you can just look at that in your notes. I don't have that luxury because we'd be scrolling back up and down, up and down. So you don't have to rewrite this every time for every problem. You can just look at it in your notes. I don't have that option. Now, one problem though is these, the way they're oriented, they're not in the same order. We need to get them so that they're in the same order. So I'm going to actually take my triangle and I'm going to make sure to line up the right angles. Right now, on the problem we're working with, the right angle's in the top right corner. Now my right angle is in the same corner. So now I can decide what goes together. Looking at 3, what does 3 go with on our formula triangle? X. So 3 and X, they're equal to each other. They're in the same spot. What about B? What does B equal? B also equals X. They're in the same spot. What about A? X times square root 2. So again, this formula triangle, you don't have to have it written down for the problem. You're going to just be referring to the one in your notes. But I didn't want to have to keep sliding up and down between our two triangles. Okay, so now we have 3 equations we can work with. So our third step is we want to figure out what is x. We want to figure out what is x as a number. I could say x is b. That doesn't do me much good. I want to find x as a number. So we focus on the side that started out as a number. We start out looking at 3 equals x. If x is already alone, we're good. We'll see on the next problem what to do if x is not already alone. We just want to make sure x is alone. On this one, x is alone. So what do we know x equals? It's a number. 3. X is 3. So now in each of the equations that I have, I can replace the letter x with the number I know it equals. In this equation, instead of writing x here, what should I write now that I know what x is? 3. So a is 3 square root 2.
Wait, how did you get 3? Was it just from the one up there?
Yep, just from that equation.
Okay.
If that equation tells us what x is right off the bat, we know what x is. What about this equation? What can I replace x with? 3 again. So now I have my two answers. I know a is 3 square root 2, and I know b is 3.
Is it the answer?
Yep, those are the two answers. All of these problems should have two answers because we're trying to find two sides. Okay, so let's try a second one together. We're going to try a second one. This time it's going to be a 30, 60, 90 instead of a 45, 45, 90.
This is the last example we have.
Then we're going to do a try problem.
And then we're done.
Yes.
Can I use the podcast when we're done?
So again, it asks us to find the missing links. How do I know that this is a 30, 60, 90 triangle?
Because there's a 30-degree angle.
We look at the angles inside. Since there's a 30 degrees and a 90 degrees, we know the last one is 60 degrees. So again, we've got to look at that formula triangle we already have. This time I'm not going to scroll up, I'm just going to draw it in. X, 2x, and x times square root 3. But we will have to rotate our notes or rotate our assignment paper so that we get the right angle in the same direction, so that we can figure out a little easier what goes together. So if we rotate that around, what does m go with? Just plain old x. This side goes with just x. So m goes with x. What about n? What does that go with? 2x. N goes with 2x. What about 5 square root 3? What does that go with? X times square root 3. Again, this is not something you need to write down for every problem. You just needed to use it temporarily. So you're going to be looking at those top two formulas in your notes quite often to get all of this information. Now once we have those three equations, we start by getting x alone. And I picked this last equation because it was the only one that didn't have an m or an n. It had only x's. We want to work with the equation first that only has x's. So I've got to get that x alone. What can I do to get x alone?
You can do 5 times x and then 3 times 3, which equals 9, and then solve it from there. That's why I was starting.
I think you're making it more complicated than it needs to be. There's a quicker, faster way. When we want to get x alone, we're always trying to do opposite operations.
Also, you'd square it.
Close. We divide it.
Oh, snap.
That's x times square root 3. I would divide by square root 3.
Okay. Makes sense.
Well, what happens here when we divide by square root 3?
So you just go ahead and it's just 5.
You go in, it's just 5. So we figured out what x is. Now we use that in our other two equations. I replace x in both equations. So m, if I replace x, what am I going to put here instead of x?
5.
5. And same idea. If I replace x, I had 2x. What's going to go in the spot that x was? 5. But this time I had a 2 to interact with. What do I do with a 2 times a 5? Multiply them together, so
N equals 10.
we get n equals 10. So figuring out what x equals isn't our final answer. It's kind of an in-between step. Figuring out what m and n are, or a and b, they're going to use different letters. That's our final answer. So let's try one more problem. This one I'm going to have you try on your own first. So I'm going to give you a couple minutes where I'll walk around and see how people are doing. And then we'll get started on the assignment.